let's remind ourselves what we know about the slopes of parallel and perpendicular lines. So if two lines are parallel, then their slopes are... Yeah, I was going for equal, yes. If two lines are parallel, then their slopes are equal. If two lines are perpendicular, then their slopes are opposite reciprocals. Or you could say their product is never -1. Remember, if you find the product of two slopes and you get -1, then they are perpendicular. All right, so go ahead and answer these 5 with parallel, perpendicular, or neither. First one you say is parallel. Very good. What's the slope of this line? Y equals 5. Well, the slope is 0. What's the slope of this line? 0. When the slopes are equivalent, the word you like to use, when they're equal, then our lines are parallel. All right, Aaliyah, what'd you get on the second one? Very, very good. Perpendicular. So the slope of this one is 0. The slope of x equals 8 is undefined. Did I trick some of you by putting, you know how they both equal 8? Did you think it was parallel because they both had a slope of 8? Did I trick anybody? Or are y'all untrickable? Be careful. Y equals a constant is a horizontal line. X equals a constant is a vertical line. Horizontal line and vertical line perpendicular. Okay, Jane, what did you get for C? Very good. C is neither because 4 and -4 are not opposite reciprocals and they're not equal. Ralph, D. Perpendicular, very good. Perpendicular. -1 and 1, believe it or not, are opposite reciprocals because the reciprocal of 1 is 1. And last one, Brian, what'd you get? Very good, Brian. Parallel, because a slope of 6 is equal to a slope of 6. Awesome. Here are the answers to the homework that was called linear equations, and then I'll show the answers to the one called writing equations of lines. Here's the next set of answers. So this is the one to writing equations of lines. So this is a good question to ask because we're actually talking about perpendicular bisectors all day today. It's the title of the lesson. So the perpendicular bisector of the segment joining 7, -5, and -13, 0. Now, that word, perpendicular bisector, has a lot of meaning in it. Perpendicular means, obviously, that they're going to intersect at a 90-degree angle. And bisector, there's the symbol for bisector, it means it's going to cut our segment in half. That means it's going to pass through the midpoint. Yes, good. So let's start by finding the midpoint. To find the midpoint, you add your x's and divide by 2, and add your y's and divide by 2. Okay. So what would the midpoint of this segment be? I'm getting, and you can do a fraction or a decimal, I'm getting -3, -2.5. Or you could put -3, -5 halves. Are we okay with that part? So we have a point. Now we need a slope, because to write the equation of a line, you need a point and a slope. So let's get a slope. Let's do slope formula. Okay, slope formula says delta y over delta x. So we have 5 over -20. So -1/4. And we want to be perpendicular to that. So perpendicular to -1/4 would be 4. So we have a point, we have a slope. We're ready to write the equation of our line. So point slope form says y minus y equals m x minus x. Let me know if I make any errors as I'm doing this because I'm going to go quickly. Y plus 2.5. If you don't mind, I'm going to put that back into fraction form so that we can see it better. Are we okay with that so far? What I did there? Distributed, put it back into fraction form, because I want to know what to multiply by to get rid of the fraction. What are we going to multiply everything by to get rid of that fraction? 2. So I'll have 2y plus 5 equals 8x plus 24. I'm going to move the 8x over and the 5 over at the same time, if that's okay. And then the leading coefficient is not allowed to be negative. So 8x minus 2y equals negative. Oops, that's not a negative symbol. Did I lose anybody? All right, I was asked just to take an equation in slope-intercept form and move it to standard form. So let's do that. You can do this many different ways in many different orders, but I like to get rid of the fractions first. So I would get rid of the fraction first by multiplying everything by 2. 2y equals 3x plus 4. Every time you take what's in the denominator and you multiply everything by that number in the denominator is going to be gone. And whatever else was there, that'll be left. So that's how I got 3. Okay? Now I'm going to move my x over. Negative 3x plus 2y equals 4. And then I'm disobeying one of those two rules. The leading coefficient cannot be negative. And so I multiply everything by negative 1, which changes every part, every term, it changes their sign. So we have that. Today's lesson is going to be one of those where we kind of just discover everything. So it's not like I'm going to tell you something and then we're going to practice, practice, practice. We're going to mainly spend the whole class discovering what today's lesson is, okay? I need you to draw a coordinate plane real quick on in your notes, wherever you take notes. So if you have a ruler today, because I told y'all to bring rulers, so if you could do me a favor and use a ruler, that would help. You want to put A at 1, 1, and then 2, 3, well that wasn't even, 4, 5, 6, 7, and B at 7, 1. It would be the best to do it on graph paper, but I know you don't all have graph paper. So we're just going to go with this. All right, go ahead and connect A to B to create segment AB. What's the length of segment AB, by the way? What's the length? Next it says to draw the perpendicular bisector of AB. So we know, remember we talked about that is a loaded word, right? There's a lot in that word. Perpendicular means let's make sure it intersects at a 90-degree angle. And bisector means let's make sure we go through the midpoint. So what is the midpoint of your segment? What's the midpoint of AB? So we need to be a bisector. We need a midpoint. And our midpoint is 4, 1. 1, 2, 3, 4, 1. Draw the perpendicular bisector. So we're going to draw the line that goes through that midpoint. And we're going to draw it at 90 degrees to AB. It said to name it L. So I have segment AB, and then I have line L, which is my perpendicular bisector. All right, so now it says to name the intersection of the, what does this mean? I use symbols there. That's perpendicular, and B with a circle around it is bisector, okay? Name the intersection of the perpendicular bisector and AB, point M. So I'm going to name it M. M for middle, right? Number 4 says, what is true about the distance from A to M and the distance from M to B? What is true about the distance from A to M and the distance from M to B? Of course, because M is a midpoint. So you could write this on your paper, or you could write this. Remember, we use congruent with segments, and we use equal with distance. If you don't put a line over it, it's distance. It's not wrong, but it's distance. Next, pick any point on line L and name it C. So we can all pick different points. But please make sure you pick like whole number points, like 4, 7, or 4, 2, or 4, -3. Don't pick over 4 up 7.25. Don't do that on me. All right, everyone picked a C. Step 6, find the distance from A to C and the distance from B to C using the distance formula. Remember, the cousin of distance formula is Pythagorean theorem, so if you would rather just use Pythagorean theorem, that's A-okay. It says compare your findings with your group. We'll compare with each other in a minute. And then we're going to make a conjecture about any point that lies on line L. Please find the distance from A to C and the distance from B to C. So using what you just discovered, please write a sentence about my diagram using the word equidistant. Write a sentence about that exact diagram, use those letters on your paper using the word equidistant. Equidistant means equal distance. Here's what I was looking for. Here's what I was hoping you would say. Any point that lies on, what do you think I'm going to say? Any point that lies on segment CD is equidistant from what? Write that in your notes. That is the perpendicular bisector theorem, but except it's specific to this one picture. But that's pretty much the perpendicular bisector theorem. Any point that lies on segment CD is equidistant from points A and B. So what that's saying is I can pick any point. How many points are here? Infinite. An infinite number of points. And any of those points would be equidistant from A as it is from B. That is today's theorem. AC would equal BC, no matter what point you picked. Okay, write that down in your notes, and then we'll do some constructing. This slide is just a quick reminder. Just watch me. You do not have to do it. How did we construct a perpendicular bisector given a segment? So how we did that was we put the needle on the end point. We went more than halfway, and we made an arc. The key was more than halfway. Okay? Then we flipped our compass over, and we put the needle on the other end point, and we made the same exact arc facing a different way. We kept the radius the same the whole time. Then we connected the dots of where those two arcs intersect. Connect the dots with a ruler, not with a free hand like me, and that is how we construct a perpendicular bisector. Now that is not new. We learned that another unit. What is new today is we need to know how to construct a line perpendicular to another line through a given point. So you can't just do any perpendicular line you want. You have to do it through a given point. So if you have time, you can try it with me. Draw a quick line on your paper with a ruler. Draw a line. And then anywhere above the line you want, put point P. Anywhere above the line. You can do this one with me because it's new. Okay, here's how. There's only one extra step to do this than there was in the last one. It's super easy. So, on the last one, we had endpoints of a segment, right? Well, a line doesn't have endpoints, so I don't know where to put my needle. So we need to create those endpoints. They can't just be any two endpoints we want. We can't just eyeball it and be like, okay, got my endpoints. Nope, we can't do that. We have to create specific endpoints. So the way we're going to do that is we're going to put our needle on P. My dot is so huge. Anyways, you put your needle on P, and you make a little semicircle intersecting your line. Now, I have points A and B. Now, I have my endpoints. So now I can construct a perpendicular bisector like I did last time. I put my needle on A, and I go more than halfway and make an arc. And then I flip it over and put my needle on B. and go more than halfway and make an arc. And when I connect the intersections, there is my line perpendicular to line L through point P. So that's how you construct a line perpendicular to a given line through a given point. What did we do extra? We just made that first little extra arc. I made arc AB. Well, the arc that created points AB. Okay? Before we get to the proof, which is the very last slide, let me make sure we all learned what we were supposed to learn today. So we had segment AB, and today we learned if you draw the perpendicular bisector of segment AB, what you were supposed to learn today was that any point on this line, any point, an arbitrary point, as long as it's on that perpendicular bisector, it is equidistant from A and B. So we learned today that this distance is the same, as that distance right there. That's the main thing that you're going to use on your homework tonight. Okay, now let's do the proof. We are not to the point where you guys are having to write proofs on your own. We're getting there soon. We're still taking baby steps, but we're going to do this proof together just because the more times you see something, the more familiar you're going to be with it. So let's look and see what we're given and how to even begin a proof. It says, prove that a line perpendicular to one of two parallel lines is also perpendicular to the other line. So when you have a proof, you always have a given and you always have a prove. It's like, here's what you get, now here's your challenge. So we were given RS is perpendicular to CD. That's what we're given. And you always start with the given. So I have absolutely for sure, I know what to start with. RS is perpendicular to CD. And what's the reason? Oh my goodness, it was given to me. So every student knows how to start a proof. After that, it's kind of confusing where to go, but that's why for now we're going to do fill-in-the-blank proofs. And you're welcome to just watch this so you don't have to write it down. There's not going to be anything on the test where you have to write a proof by yourself. Okay? All right. It says that since RS is perpendicular to CD, the measure of angle 1 is 90. We need to give the reason. Because we said so? Because we felt like it? No. What's the reason the angle 1 is 90? We have to use a definition, a theorem, or a postulate. Good, Neil, but you just need to put something in front of that. Definition of perpendicular lines. So that's the reason. Yep, definition of perpendicular lines. So either definition, theorem, or postulate. Okay, then we stop there and we go to our other given. See how we know that the other given comes next because the reason already says given? So the other given is that AB is parallel to CD. Given. All right, now we need to say something, and we need to use the corresponding angles theorem. So what would you want to say about our picture using the corresponding angles theorem? What would you want to say next? No, say that differently. So next we're going to say angle 1 and angle 2. That's the ones we're looking at. So the measure of angle 1 is equivalent to the measure of angle 2 by the corresponding angles theorem. Because that theorem says if two lines are parallel, then corresponding angles are congruent. Okay? Next, you want to say that the measure of angle 2 is 90, don't you? You said that? Yep. So we're going to use substitution, and we're going to say that the measure of angle 2 is 90. Because if the measure of angle 1 equals the measure of angle 2, and the measure of angle 1 is 90, well then 90 equals the measure of angle 2. You don't write that in your proof, I was just showing you that. And what did we do? We used substitution. How do you always end a proof? How do you end a proof? With the prove. So now we know RS is perpendicular to, I can't see my picture, AB. And what's the reason for that? We said angle 1 was 90. Then we said angle 1 equals angle 2. So now we know that angle 2 is 90, because if angle 1 is 90 and they're equal, then angle 2 is 90. Okay? And if I know angle 2 is 90, how do I get from that being 90 to these being perpendicular? So the last thing is, once again, we can use it again, it's definition of perpendicular lines. If we know an angle is 90, then we know the lines that create that angle are perpendicular. Woo! So if you want to copy down the whole thing, I'll leave it right there. Okay?